everyone, and welcome back to the Science Corner. Now, Miss Bowman was a little sneaky yesterday, so I took my water that we used from our washing rocks and I kept the water overnight because when I went to dump it out, I noticed that some of the pieces in the water were kind of sinking down to the bottom and the water was getting more and more clear. So I wanted to see if I left it overnight, what would happen to that water. And it did get a lot more clear than it was yesterday, so take a look. It's still a little murky, but you can see there's lots of stuff in the bottom of that cup and not a whole lot left in the water. You can kind of see through it. So I did my own experiment. I just wanted to see what would happen if I left that water to sit all night, how much of that part of those particles would sink to the bottom. So for today, we're going to talk more about our 6 rocks that we have. We have our basalt, our tuff, and our coria. But before we do that, I want to talk to you about volcanoes. So, what do you already know about volcanoes? Volcanoes are super dangerous because they heat up rocks so hot that they turn into a liquid and then they shoot out the top of the volcano and run down the side. Do you know what that material is called? Right, it's called lava or magma. Some lava moves quickly and some lava moves slowly. Check out this video. Take a minute and add some of the things you noticed from that video onto the bottom of your page from yesterday. What are some things you noticed? Now let's check out this video to learn more about volcanoes.
Hey Geo, check out these temperature readings from one of our underground sensors. It seems like the ground has a fever.
Actually, the rocks under that particular mountain have warmed up a bit recently.
What could heat up the rocks?
Volcanic activity.
You mean hot lava and all that?
Yes, but this mountain was thought to be an extinct volcano.
But Geo, I thought dinosaurs were extinct, not mountains.
Tell you what, Iggy, why don't we link up our data banks and I'll share with you all the information in my files about volcanoes.
I would lava it. Get it?
I can see we better get started. Iggy, think of the Earth as a hard-boiled egg. Like an egg, the Earth has layers inside. The center of the Earth is called its core and is made of solid metal that's very hot. The mantle surrounds the core just as the egg white surrounds the yolk. The mantle is made of hot melted rock called magma. A volcano is a mountain built by magma and gases that erupt or flow out of the Earth. Once magma reaches the surface of the Earth, it's called lava. As this lava cools, it hardens into rock and forms the volcano.
So, if we think of the Earth as an egg, what's the eggshell?
The eggshell is like the Earth's outer layer or crust. It's very thin compared to the layers beneath it and is made of hard rock.
Okay, but why does melted rock flow out of the Earth's crust?
Because magma is under lots of pressure from the weight of all the rocks above it. This pressure can force the magma out through weak areas in the Earth's surface, causing eruptions. Not only is there a lot of pressure from the weight of the rocks above the magma, but there's even more pressure caused by all the heat. You see, as things heat up, they expand or swell, if they can. If they can't expand, the pressure on them increases. It's like leaving a can of soda in the sun. It heats up and becomes kind of swollen. The pressure inside the can grows. When the hot can is opened, it releases all this pressure by spraying out soda and foam.
This is all pretty cool, Geo, but what makes the weak spots in the Earth's crust where magma can get out?
Good question. Let's go back to our egg. When an egg is boiled too long, the increased pressure inside causes the shell to crack.
Are you saying the Earth's crust is cracked?
Yes, I am. Though the Earth's crust is made of hard rock, the movements of the hot liquid mantle under it have cracked it into large pieces called plates. The plates fit together like a jigsaw puzzle. It's at the edges of these puzzle piece plates that most volcanoes occur.
So the magma is just escaping through natural cracks?
Yes, at the seams or edges of plates. This happens even more often under the ocean, where the Earth's crust is thinner than on dry land. When plates slowly pull apart under the ocean, a crack appears in the sea bottom. Magma erupts there and hardens. Sometimes an underwater volcano can grow so tall that it rises up out of the water, forming an island.
So let's see if I've got it right. The Earth has layers, and we're on the top one, known as the crust. The next layer down is the mantle, made of molten magma. Pressure forces the hot magma out through weak spots in the crust through eruptions. Once the magma escapes the Earth's interior, it's called lava. And it's this lava that cools and builds up to form volcanoes.
I think you've got it.
But it seems that once they're formed, volcanoes look a lot like mountains. What makes them different?
It's what's going on inside the volcano that makes it different from other mountains. If you could slice a volcano in half with a huge butter knife, this is what it would look like. The magma often pools just under the surface of the Earth in a huge reservoir or magma chamber.
Talk about a hot tub.
As the magma moves up through a weak spot in the crust, it forms a central vent through which the lava can escape. The funnel-shaped opening created at the top of the vent is called a crater.
Does the lava always come out through the crater?
Not necessarily. Sometimes lava can ooze out of cracks on the side of the volcano.
Geo, I've been wondering, are there different kinds of volcanoes? I mean, some look so different from others.
Yes, Iggy, there are actually 3 kinds of volcanoes. The first is what is known as a shield volcano, in which the lava is runny and flows down the sides of the volcano, forming a wide shield-like shape when it hardens. This shield can get built up layer after layer through different eruptions. But there's a lot of hot gas mixed in with this lava, and it can sometimes spew bright fountains high in the air.
That's pretty impressive.
Let's take a closer look with a little demonstration.
Today, we're going to demonstrate how a volcano erupts by building a model. However, it's important to remember that this will not be exactly the way a volcano erupts. It's only an imitation. For our demonstration, you'll need to wear aprons, safety goggles, and gloves. You'll also need 60 milliliters of liquid soap, 60 milliliters of baking soda, 60 milliliters of red powdered watercolor paint, 60 milliliters of white vinegar, 1 medium-sized plastic soda bottle, a pail full of moist soil, a large beaker and stirring rod, a large baking pan, and a funnel. Place the open soda bottle in the baking pan. The bottle will represent your volcano's magma chamber. Next, pack the soil around the bottle in a large cone, with the tip of the cone ending just below the mouth of the bottle. The soil will represent the mountain around your magma chamber, and the mouth of the bottle will represent the crater. Now, carefully mix your liquid soap, baking soda, and powdered paint. Using the funnel, carefully pour the mixture into the bottle. Your magma is now in the magma chamber of your volcano and almost ready to flow out, but you need one last ingredient: pressure. In a real volcano, the magma would be under pressure from heat, gases, and the weight of the Earth's crust pressing down. In our demonstration, we'll simulate this pressure by adding vinegar in order to cause a chemical reaction. Quickly pour the vinegar into the bottle. Remove the funnel, stand back, and see what happens. Your magma should begin to bubble and expand. It will flow out of the mouth of the bottle as foamy red lava. If this were real lava, it would be really hot. Then it would cool and harden, and over time and many eruptions will build up layers of rock on the side of your volcano.
Now, Iggy, as interesting as shield volcanoes are, they're not nearly as impressive as the volcanoes that are explosive.
Some volcanoes explode?
Yes, they do. They're called cinder cone volcanoes, and they explode in fiery clouds of ash rather than flowing lava. You see, sometimes lava will cool and block a volcano's vent. Lots of pressure builds up when a volcano is clogged. The plug in the vent is like this plastic cap on a bottle of soda sitting in the sun. The pressure builds until...
Boom! It blows off the cap!
Exactly. And when a cinder cone volcano explodes, pieces of varying sizes are sent sky high. Some are finer than sand, others the size of a house. These pieces, or cinders, give the cinder cone its name. And the way they fall and pile up creates a cone-shaped mountain with very steep sides. When shield or cinder cone volcanoes build up layers of cinder and layers of hardened lava, they're called composite volcanoes. Composite volcanoes tend to have fairly steep, even sides. When they are snow-covered, they often make great places for people to ski or mountain climb. But they may just be sleeping giants. It was a beautiful August day in Italy in CE 79. The Italians of Pompeii were not worried about living at the base of a volcano. Mount Vesuvius had been a quiet mountain.
Why do I get the feeling that didn't last?
Without warning, Mount Vesuvius erupted, covering Pompeii with extremely hot ash while releasing deadly gases into the air. The ash hardened like wet cement, making molds of some people and covering buildings. Over 1,500 years later, the city was rediscovered, perfectly preserved.
All this information about volcanoes is hot stuff, Geo, but let me double check my memory banks. I now know what a volcano is, a mountain built by lava that cooled and hardened. Magma erupts through weak places in the Earth's crust, where the plates are separated. When the magma reaches the surface, it is called lava. We know magma comes from the melted rock of the Earth's mantle. And we know that pressure causes volcanoes to erupt. You've also shown me the different types of volcanoes: shield, cinder cone, and composite volcanoes.
Great work, Iggy. Now let's take a look at the way scientists group volcanoes by how often they erupt. You see, there are active volcanoes that erupt constantly or regularly.
And the non-erupting kind?
Those are called dormant volcanoes. They have erupted in the past, but not recently.
So dormant volcanoes don't show any kind of activity?
Not necessarily. While dormant volcanoes haven't erupted in a while, they often do show some signs of activity. Let's take a look at that now.
Located in the western United States, Mammoth Mountain is a great example of a dormant volcano. There hasn't been an eruption in this area of California for hundreds of years. However, much of the area around the mountain shows signs that hot magma isn't too far underground. In some areas, the ground itself is hot to the touch, while in other areas there are bubbling mud pots and steaming volcanic rocks and holes. Some of these are so hot that people have to be kept away from them. They may be fascinating, but they are also dangerous. But what's this? Is it someone's hot tub? Actually, it's a beautiful pool of boiling hot water warmed by underground magma. While this pool is far too hot to sit in, the waters nearby are just the right temperature for those looking to take a swim. This is Hot Creek, a mountain stream that mixes with spring water that is heated by underground magma. It all begins deep underground where a dome of hot magma heats cold underground water. This water then rises up out of springs at Hot Creek, creating a wonderful natural setting. But like the other signs of underground volcanic activity, the springs at Hot Creek are a sure sign that while dormant, Mammoth Mountain may one day come back to life.
Okay, dormant volcanoes haven't erupted recently. But what about volcanoes that haven't erupted for a very, very long time?
They are called extinct volcanoes. They haven't erupted for thousands of years and have often been worn down to the hardened magma chamber.
So the best volcano is an extinct volcano, right? They're much safer.
Well, Iggy, extinct volcanoes may be less dangerous than active volcanoes, but active volcanoes can actually help the Earth in many ways.
Really?
Yes, you see, new land is formed when volcanoes erupt. The Hawaiian Islands, for instance, were created by volcanoes. And after the cooled lava rock breaks down, it becomes great soil that is perfect for farming. Volcanic eruptions provide us with other useful things too. Diamonds are mined from old volcanoes in South Africa. Ash and lava are used to pave our roads as well. Not only that, but volcanoes have recently been used as sources for energy.
Really? Can you show me an example?
Actually, Iggy, I'm going to need a little help on that. My files aren't complete.
Then let's call up the Kids Into Doing Science Club for more information.
Hello, you've reached Kids Into Doing Science. This is Brian.
Hello, Brian. This is Iggy and Geo.
Hey guys, what can I do for you?
Brian, can you show us an example of how people use volcanic heat to create energy?
Here you go. People have been able to use the water heated by underground magma to create electrical power. Superheated water is pumped out of wells near volcanoes. This water is transported through pipes to large turbines, which turn huge generators. The generators create the electrical power.
Wow, that's really a good idea. Thanks, Brian.
No problem. See ya.
Even though volcanoes do so much good, it would still be a good idea not to be near one when it erupts. But how can anyone know when a volcano will erupt?
Volcanoes often give warnings, and scientists are developing new ways to tap into the signs and clues. One of the most common devices used today is a tilt meter. This is a device that measures how much the sides of a volcano are tilting. Remember how we talked about the pressure that builds up in a volcano? Well, the strain of all that pressure causes the ground to swell.
So this tilt meter measures how much the ground swells.
Right, but sometimes you can even see the swelling. A great example of this is Mount St. Helens in the northwestern United States. Before the 1980 eruption, the entire north face of the mountain swelled, helping scientists predict the coming eruption in time to warn people to leave before the volcano erupted.
So thanks to the scientists, a lot of lives were saved.
Absolutely. When Mount St. Helens blew its top, there was an avalanche as the falling mountainside and melted snow created a giant mudslide. Everything within 8 miles of the volcano was destroyed. There was another tool the scientists used to predict fairly precisely when Mount St. Helens would erupt. A seismograph measures and records earthquakes. Shortly before Mount St. Helens erupted, more than 40 earthquakes an hour were being recorded on seismographs. Iggy, let's conclude with a sort of beginning. Would you like to hear about the birth of a modern volcano?
You mean new volcanoes are still being created?
They sure are. One day in 1943, Dionisio Pulido was plowing his cornfield near the Mexican village of Paracutan. The earth began to rumble and shake. These earthquakes wouldn't stop. The earthquakes continued for 2 weeks. Suddenly, a deep fracture ripped open the land. Steam, dust, rock, and ashes poured out high into the air. The explosions of lava and ash continued for several weeks, and the volcano filled up the entire cornfield. During its first year of eruption, the Paracutan volcano covered over 2 nearby villages, and it continued to erupt off and on for 8 more years, eventually covering about 25 square kilometers or 10 square miles of land.
Wow, that guy was a volcano farmer, and what a crop he grew!
Well, Iggy, you've taken in a lot of information about volcanoes.
I sure have. My files are so full they're erupting, but let me see if I've got it all straight. A volcano is the mountain built by lava as it erupts out of weak places in the Earth's crust and cools and hardens. Before it comes out of the Earth, lava is magma, and the mantle of the Earth is full of magma. Pressure on this magma is what forces it to the surface when it finds a way. The way is provided by the cracks in the Earth's crust where the plates meet. There are 3 kinds of volcanoes: shield volcanoes, cinder cones, and composite volcanoes. Volcanoes are either active, dormant, or extinct. But even extinct volcanoes can suddenly come to life.
And the benefits of volcanoes?
They build land and provide great soil. People are even using the heat from volcanoes for energy.
And how about predicting volcanoes?
The swelling of volcanoes and earthquakes give clues they are about to erupt. And there are other signs including steaming rocks and holes.
Excellent work, Iggy. Scientists continue to study volcanoes and learn more about them. But no one knows when a dormant volcano will erupt, or when a new volcano will be created.
Who knows? But if that remote temperature sensor reading keeps climbing, we may be watching a dormant volcano waking up right now.
Let's check out our rocks that we had from yesterday. If you have yours, you can grab them back out. We're going to look at the basalt first, so that really dark, hard, gray one. So this is a gray, hard rock. It was once the hot liquid that came out of the volcano and ran down the sides. But now it's hard because it has cooled off. Now let's look at our tuff. Our tuff is that chalky kind of one that's white. This rock is made from the ash that comes out of the volcanoes. So that cloud of ash that comes out can form into rocks, which is why it's so soft. Now let's check out our scoria. So this scoria is hard, but it's also filled with bubbles. This was the foamy top part of that lava that came out. So the scoria would be on top where it gets lots and lots of air, and the basalt would be on the bottom where there's no air and it's so thick and it hardens as it goes. So what can you tell me about all three of our rocks? That's right, they all came out of a volcano. I think that's really cool. Who knew a volcano could produce such different rocks? Well, that's all for our Science Corner today, and I'll see you next time. Bye! More about our 6 rocks that we have: our basalt,